Okay, so what we're going to be moving on is to chapter 8, which is dealing with exponential and logarithmic functions. And so what we're going to be doing now is that we're going to be doing an introduction of exponential functions and looking at what they are. All right, so this function right here, that is your exponential functions. We have either an exponential growth or decay. It's called an exponential because our variable is up in the exponent. Okay, so we have something something to the x power, and those are your exponential. The a value is your y-intercept. Okay, so the number that's not being multiplied by the x is your y-intercept, and then the b value is your either exponential growth or exponential decay, depending on if it is greater than 1 or between 0 and 1. So if you have a number like 3, so if you have 3 to the x, that is an exponential growth because it's larger than 1. But if you have like 0.75 to the x, that is a decay. Okay. Now how you might see these written, you might have it as y equals 19 0.85 x. This is how it would be written out. This y, or this 19, is your y-intercept. This is your growth or decay, and since it's less than 1, we would consider it a decay. Okay. So it'd be a decay in this case. And then x is your variable. Usually x is time. So let's look at this one. So the population of the U.S. is increasing at a rate of 1.4%. The population in 2000 was 281 million. Create a formula to calculate the population in 2015. So when we write our formula, since we're dealing with a percent, we're going to have to put this percent into a decimal, which would be 0.014. Okay, that would be it in percent. But since it's increasing by that much, we have to add 1 to it. And so that's why we get 1.014. And that is our increase or decrease. Now, if we want to find in 2015 how many people, we would calculate, okay, what's the difference between 2000 and 2015? 15 years. And we would plug a 15 in for x. So we'd go 1.014 to the 15th, and then multiply it by 281, which gets us about 364, and we'd say millions because that's what we're taking it into. Okay. So that is your exponential. All right, so now let's say we're given 2 points and we want to find the equation for it. So what we'll do is we'll set up our equation, y equals abx. Okay, and we have to find the a and we have to find the b, but we know the x and y. So we're going to plug in a 4. It's going to be 4 is equal to ab squared. Okay. And now we're going to solve for a, which will get us a is equal to 4 over b squared. Now we're going to take this and we're going to plug it into our next equation, which is going to be set up as 16 is equal to b to the third, and we're going to put this in there for the a. 4 over b cubed, or b squared. B squared. And now we will reduce this. We will simplify and solve for b. Well, b over 3 times b, 3 over b to the third times 1 over b squared gets us down to b. So we have 4b is equal to 16, which means b is equal to 4. So now we know what b is. It's 4. That's from us just solving. Remember, when you take b cubed over b squared, that reduces down to just b. You subtract the exponents. So now we have b equals 4. We plug that into here. So we have 4 all over 4 squared, which gets us 1/4. So our answer looks like it's going to be y is equal to 1/4 times 4 to the x. And that would be our equation. Alright, so now looking at this one. So this first one, we'll set up, we have 8 1/3 is equal to ab to the negative 1, We solve for a. A is equal to 8 1/3 all over b to the negative 1. Now we're going to take this and plug it into the next one, which would be 1.8 is equal to 8 1/3 all over b to the negative 1 times b squared. That looks like it gets us 1.8 is equal to 8 1/3 times b to the third. And now we solve for b. Okay, and then we take whatever we get for b, plug it in here, and then solve for a. And we end up getting approximately that answer. Okay, and so now the next one, our first setup will go 0, or no, we've got 24 is equal to a b to the 0. Well, since b to the 0 is 1, we can say a is equal to 24. And so now all we have to do is we'll go 8 ninths is equal to 24 times b to the third, and then solve for b. So you would divide, so it'd be 8 over 9 all over 24 is equal to b cubed. You'll take the cube root of both sides to get rid of that, and that gets us our answer for b, which is about 1/3, and we'd have 24 times 1/3 x. Okay. Here's your IRAP. First one, find the exponential function, so like what we just did in the previous one. So find that function. So you're going to plug this in for the x and this in for the y, solve for a, and then plug this in for the x, this in for the y, and solve for b. And then you're going to use the one you previously found to plug into the next one. And then the last two, all you have to do is state if it's an exponential growth or if it's a decay. All right.